Hello, my dear students and friends. So, welcome to our RSV Physics class. So, this is lecture 1 on magnetic effect of current. So, basically, moving charge and magnetism. Hello, electric current also produce magnetic field. So quickly I will describe on the history of this magnetism. Okay, so basically history is the Magnus has discovered some leading stone in Asia region. So this stone is made of Fe3O4. So ferric oxide, this stone has two properties. One, its attractional property, and another one is directionality. It is oriented in particular direction. So if you put the stone with a thread and it hang it, then this stone, whatever may be the rotation, you just rotate it. After, when it is stabilized, it will only stable in north and south direction. So this is called, that's why it is called so leading stone. Okay, so this is the history of magnet. And then different types of artificial magnet there is also there, you can create in a lab also. So nickel, cobalt, and Fe. So if you rub with magnet, then there is a induction in that you learn from your previous school classes. Okay, so you just rub it with a bar magnet. What is bar magnet? It is made of N and S. So magnetic monopole doesn't exist. If you cannot create north pole and south pole, whatever may be the division you can do, but there is a small teeny particle of this Fe or nickel cobalt material, but there is a north south, microscopic. So there is a microscopic phenomena and microscopic theory of magnetism, and then that I will explain also. Okay, so this is the bar magnet. So field line, so electromagnetic means them. So this is the long range force. So field line will be from north direction to south direction, this one, and field line will be going to infinity from north, and it will going towards, so at infinity it will be, so field lines are closed loops. Inside it will be southward to north direction. So this is the basic field lines, and there is a different magnet, bar magnet and magnetic needle. So if you put some magnetic needle here, so compass apne dekhe honge na. So this is magnetic needle. So if you stabilize, so this north pole and south pole, so it will be oriented in north south direction. Okay, later in 1820, Hans Christian Ørsted, the name you know already, Ørsted, he is first observed there is a deflection of a magnetic needle. When he put a magnetic needle here, this is a magnetic needle. Okay, and current is flowing through this rod, here this wire. Okay, so he has observed whenever the current is passing through this wire, then magnetic needle is deflecting. So Ørsted experiment is shown that, so whenever this when current is off, then it is coming to its own position where it is been kept. But when current is passing, then north pole it is attracted towards it. So there is now these two laws, Ampere swimming rule and right hand thumb rule. Ampere swimming rule. So if a person is here with head is here and he is swimming and he is observing this side, and his direction is this side. Okay, he in this condition, just he is swimming on the wire. Just imagine this. So his right hand side is this side. So this ये pole जो है आपका north one is the north pole of this magnetic needle, which is attracting towards this wire, है ना. तो यहाँ पे so there is something magnetic field. Otherwise how it is attracting? So there is earth magnetism, na, north south jo hai na. So in that case magnetic needle, that's why it is magnetic needle is placing whenever we can rotate it, but it is placing north south direction because there is earth magnetic fields. And that I have explained on in another lecture also, aurora and everything, and solar storm, which is protecting our earth. Earth magnetic field is protecting from solar storm. Otherwise, life in the earth cannot exist here. So that is the very beauty of our nature. Okay. So now this deflection, it is decided by right-handed thumb rule. Right-handed thumb rules means if your thumb is here, this is your thumb, and this is your hand, and this is right hand thumb. So this is the thumb. So thumb is here. So north pole of this magnetic needle, it will be deflected this direction. So that's why this is the two laws it is governing by. It is deciding the deflection of this magnetic needle. So this is the experiment. So another, here's some wooden board, and then he put some Fe and nickel dust here. So now here is a electric wire, and now current is flowing through this. Okay, so you connected with battery, है ना? It is with battery. So current is flowing this direction. So it is observed that whenever current is just flowing, so this iron particle is arranging in a closed loop, also circularly arranged. So it is governed by, so that's why it is evidence that whenever current is there, like electric line is flowing, so there is a magnetic field, closed loop. So magnetic field is producing. That's why this. So it is magnetic field is producing. So this now how this field line is there? This is just like a closed loop, and the which direction is decided by two laws: Maxwell corkscrew rule and right-handed grip rule. So if it is your right hand, it is your grip. So if it is current direction and grip is this direction, matlab corkscrew. Matlab whenever screw is here, so if you tight it, if you screw tight it, it is going this direction. So this is the current direction, and if you rotate it screw, so it is a screw type, hai na? So it is a screw. So if you rotate this direction, so it is going this direction. So that if your current is flowing, then direction of the magnetic field will be just clockwise. Okay, so that's why this is the magnetic field direction. So this is north and this is south. Okay, so that's why the magnetic needle's north pole is attracting here, because here north and south pole is there. So that's why it is attracting here. So this is direction of this magnetic field and area lines is decided by the Maxwell corkscrew rule and right hand grip rule. So all the things you have learned your below class 10 level also. Okay, so this is a recapitulation. Now we will be calculating the magnetic field, its amplitude. So magnetic field, it is denoted by A, and amplitude is B vector. Now how can you decide this? Let's see. Now magnitude of the magnetic field B can be calculated using Biot-Savart law. What Biot-Savart law is telling? If a current carrying conductor, it is XY. So this is carrying current, I current. Okay. So there is a small element dl, and you are calculating magnetic field at distance p, which is r distance. Okay, so this is r. So magnetic field at p point due to current carrying conductor xy is small b, d proportional to carrying current I, dB proportional to dl, and proportional to the angle between, this is the angle of dl and this is the position, and at what position you are calculating, the angle between is proportional to sine theta and also proportional to distance. This is a long range force, magnetic force. So here the magnetic field is proportional to 1 upon r square. So dB proportional to I dl sine theta over r square. So there is a proportionality constant, dB equal to mu 0 over 4 pi I dl sine theta over r square. So mu 0 is your free space permittivity. Free space, this is free space permittivity. Okay, it is 4 pi into 10 to the power minus 7 Henry per meter और टेस्ला मीटर जो है पर एम्पियर. Okay, so mu 0, this is okay. Now if you want to calculate total B for all wire over the length L, so you have to integrate over L mu 0 over 4 pi I dl sine theta over r square. Okay, so theta is the, so you can in vector notation you can also write B equal to mu 0 I, it will be coming out mu 0 I over 4 pi dl cross r vector over r cube. Okay, this is r vector and dl cross r, this is dl r sine theta. So in this term also vector notation you can also write. So this is Biot-Savart law. Okay, now using application of Biot-Savart law, but using for a straight infinite wire, how much magnetic field you have to calculate at some point. Okay, so this is some simple principle, simple applications. Okay, let's calculate it. Then for closed loop and ring we have to calculate this. These two problems we will calculate, okay, in this class. Now, so this is a simple infinite wire, straight, and there is a length dl, okay, and this is the distance. Okay, so small from center, it is, this is at L at from this is center 0, from L distance it is your dl parameter. So current is flowing in this direction. Okay, and you calculate magnetic field at P, which is your r, and this is the at x distance. Okay, now you have to calculate the magnetic field due to infinite wire, okay, or semi-infinite wire. Okay, now you have to calculate it. Let's, so this is the dl direction and this is the angle theta. Let this angle is beta. Okay, now just from this, so you know the magnetic field is your dB equal to mu 0 by 4 pi I dl sine theta over r square. This one, no? So this is the magnetic field. So you have to calculate. Now this is now think here, if your magnetic field sine theta, means if you calculate the magnetic field along the wire of direction, so along the direction of current की direction में magnetic field कितना होगा? Along the direction of the current magnetic field, you are calculating magnetic field this direction, but along the current carrying conductor, along the current direction, how much magnetic field will be there? This is the typical question, short questions. So sine theta means in that case theta will be 0. So sine theta equal to 0. So how much it is? So this is magnetic field is dB equal to 0. Okay, fine. So along this direction magnetic field will be 0. Now from this from this geometry, just see this triangle L by x equal to, this is tan beta, okay, L by x equal to tan beta, okay. So dl equal to x sec square beta d beta, you can write this, no? Okay. Now dl, this one, okay. Now theta equal to, again theta equal to how much it is, 90 degree plus beta, fine. Now from here dv equal to, acha, this is b equal to, okay, this is b equal to total integration, and dv equal to, there will not be integration sign, okay, sure. So dv equal to how much, mu 0 I over 4 pi, and dl is how much, x sec square beta d beta, and r is, अच्छा here जो है आपका d beta and sin theta how much, so this is your cos beta. So from this triangle your r over x is sec beta, है ना, this is x by r, so r equal to x sec beta. So here you can write dv equal to x sec square beta, okay. So now dv equal to mu 0 I over 4 pi, and here this is your cos beta over x, fine. So this is beta. So now for infinite wire, so this angle, beta angle, you have to vary for infinite wire, so you have to vary this angle to infinity. So at infinity it will be parallel. And again for measuring you this side angle, this dl, so you have to go further, मतलब आपको infinite तक जाना है, मतलब ये this point will be at infinity, this will be just like a parallel, okay, and here it will be parallel. So for sake of your understanding, so let's just see, let's this angle, and here this angle is, this is angle just for varying, this is, है ना, so this is your wire, है ना, अच्छा. So this wire जो है आपका यहाँ पे इसके साथ एंगल है ना, ये इस वायर के साथ जो एंगल है ना, ये this one है ना. So this angle and this angle, so let's see, this is alpha 1 and this is जो है minus of alpha 2. So this angle है ना. So आप ये आपको आप infinity के लिए this will be going to, for infinite and ये this alpha 1 and minus alpha 2 equal to 90 degree, that I will see. So now let's see here, okay. So b equal to mu 0 I over 4 pi integration of जो है cos beta by x, है ना, x तो नीचे है, so और d beta, here d beta is also here, है ना. So b equal to, and this is minus alpha 2, ये alpha 1, so b equal to how much it is, mu 0 I over 4 pi x नीचे है ना, sin alpha 1 plus sin alpha 2 minus of, ये इसका इंटीग्रेशन होगा sin, है ना, this is sin beta, है ना, and limit is minus beta alpha, and so sin beta का जगह alpha 1 and minus of sin alpha 2, so this is plus, okay. So this is integration. When you learn integration, that your life will be simpler, okay. For sake of now for infinite, this wire, if your wire is infinite, है ना, so this angle will be going, if it is infinite, so angle will be going parallel, बहुत दूर तक, है ना, so alpha 1 and alpha minus alpha 2 equal to 90 degree, okay. So B equal to, for infinite wire, how much it is? B equal to mu 0 I 4 pi x, and it will be 2 twice I, है ना, twice I. So basically is equal to mu 0 I over जो है twice pi x, this one, okay. So this is the magnetic field for our semi-infinite. Semi-infinite means one side alpha 1 equal to 0, है ना, अल्फा 1 इक्वल टू मतलब एक साइड, सेमी इनफिनिट मतलब एक साइड है और इसलिए दूसरा साइड नहीं है, और मतलब ये साइड मान लीजिए नहीं है ना, और इस साइड में इन्फिनिट तक है, सो अल्फा 1 0 एंड माइनस अल्फा 2 इक्वल टू 90 डिग्री. सो इन दैट केस क्या होगा, एक ही रहेगा, है ना. सो इन दैट केस बी इक्वल टू म्यू 0 आई ओवर 4 पाई एक्स, इसमें 1 ही रहेगा ये. सो दिस इज फॉर इन्फिनिट वायर एंड दिस इज फॉर semi-infinite, and along the direction जो है वो पहले बताया था, along the direction of the current carrying, so this is will be 0. So this is the typical example of Biot-Savart law. Using Biot-Savart law, you are calculating magnetic field. So how much it is depending, mu 0 I and I 4 pi x. X मतलब यहाँ से perpendicular distance from this wire. ओके, वायर से जितना परपेंडिकुलर डिस्टेंस है, सो ये आपका मैग्नेटिक फील्ड का ये है ना. नाउ अभी जो हम कैलकुलेट किए थे, सो दैट मैग्नेटिक फील्ड इज ड्यू टू लॉन्ग स्ट्रेट कंडक्टर. नाउ वी विल बी कंडक्टिंग मैग्नेटिक फील्ड ड्यू टू सर्कुलर कंडक्टर. सो इफ दिस इज योर सर्कुलर कंडक्टर एंड दिस इज स्मॉल dl, सो हाउ मच dB इक्वल टू म्यू 0 बाय 4 पाई I dl sin theta over r square, and this is r. So for circular conductor, now theta is where, this dl and this point, you are calculating magnetic field at center. So theta is 90 degree, theta is 90 degree, and if you calculate over b equal to, so your total integration हो जाएगा over dl, है ना. So integration will be mu 0 by 4 pi I, ये जो है integration of dl sin theta is 1, है ना, and this is the r square, so equal to mu 0 dl is 2 pi r, है ना, by 4 pi, this is 2 pi r over r square. So this is mu 0 by जो है म्यू 0 2 पाई आर है ना. सो बी इक्वल टू म्यू 0 बाय एंड आई इज हियर ना, दिस इज आई, म्यू 0 आई बाय ट्वाइस आर. सो दिस इज द मैग्नेटिक फील्ड एट द सेंटर. एंड इफ दिस इज द फॉर सिंगल वायर, एंड इफ दिस इज योर मल्टीपल वायर, n numbers of wire is here, then b equal to, for multiple n numbers of wire, equal to mu 0 n I over twice r. So this is the magnetic field at center. So I am writing here at center, b equal to mu 0 I over twice r at the center of the circle. So it is calculated in center. Now if I want to calculate an axial field, okay, on the axis the coil is placed here, है ना. So you have to calculate the magnetic field along the axis. So there is a x, this is dl, and you have to calculate along the axis, you have to calculate this point, okay, along the axis you have to calculate from this point magnetic field how much it is. So see, so dl db equal to again mu 0 by 4 pi I dl sin theta over r square. So this is your r and this is your dl, and and this is the r distance. So this loop is having radius r, this is x. Okay. Now theta. So see, considering the loop here, you are putting a loop here, and you calculate magnetic field on the axis just like this. So if your dl is here, okay, and here, matlab this one and just like your this one, and you are putting this distance. So this distance will be, this angle will be 90 degrees. So sin theta will be wash out. Okay. From geometry you just put it phi. Okay. Now for dl, if it is this is the dual. So if your dl is here and this is dl, है ना, and this is r. Okay, dl, this is dl and r. Dl cross r means magnetic field will be this direction. So this is dl and dl cross r. If you, this is dl and dl cross r, seen na, dl cross r by r cube. So dl cross r means dl to r. Okay, this will be along this direction. So magnetic field will be this direction, dB. So if you, so truly speaking, this is your dB. This is dB, magnetic field, this direction. So here this is dB cos phi, this angle, and here again this will be dB sin phi. Again for this loop, this is dl and again this is r. So dl cross r, so it will be in along this direction. So this cos component will be for this, the cos component of, for due to dl element, magnetic field is, this cos component will be this direction. So this cos component will be, again if you consider total ring, this one nullify, this one nullify. So total cos phi angle will be eliminated. Okay, so only sin phi it will remain. So just put sin phi here. Okay, so magnetic field due to this element. Okay, now magnetic field overall element, it will be in summation or integration over dl. So mu 0 by 4 pi I, dl is total, twice pi r is radius, and r square means root over of r square plus x square, and sin phi is how much? Sin phi is r over root over of, acha, this is r square, is not root over, this is r square plus x square root over of r square plus x square. So this is b by b equal to 2 pi mu 0 I over 2, mu 0 I over 2. This is r square over r square plus x square. This is 3 by 2. Okay. Now mu 0, now at the center, see, from this expression, this is, and from center you know magnetic field, for center, at the center of the magnetic field, for center how much it is, x equal to, this x will be 0. So b equal to mu 0 I over 2, x is 0 means this is 3 by 2, 3, this is twice r, mu 0 I by r, that your mu 0 I by twice r, this is r square, and here it is cube. So this is r. So that you have calculated just some time before. Okay. So now this is the magnetic field due to current carrying circular current loop on axis. And this is important. This derivation may be coming in here, and this, using this derivation you can also, there is some problem also. Okay. Now there is a application also. See here, magnetic field, if you put two circular, so magnetic field, distribution of magnetic field, पूरा along. So if your coil is here and this is current carrying I current, is it carrying I current, so along the axis how much is magnetic field will be along the axis, so this magnetic field will be this much. Okay, so as x is increasing, okay, as x is increasing, so magnetic field will be decreasing. At the center x is equal to 0, this magnetic field is maximum 2 by this is at center this magnetic field. So this will be typical plot. Now if you put two coil on an axis, two coil in axis in side distance, so this distance and so magnetic field will be how much? So according, so here your magnetic field will be for this one, and again for this one it will be this. So if you put coil in such that the magnetic you can change this coil distance, so there is a screw and you can change this two coil current carrying conductor, this is I, okay, and this is also I, okay. Now the magnetic field will be how much? In the center the magnetic field is going to be just uniform if you change it. So at some distance, when if you so maximum for maximum magnetic field in this direction, so if you put d2b, so dx2 equal to 0, so for uniform magnetic field, okay. So if you if you double derivative it, so then for this condition for uniform magnetic field, then you will be x equal to r, this distance x equal to will be r. So if you put Helmholtz, this configuration is called Helmholtz coil. Helmholtz coil. Okay. So Helmholtz coil, using the Helmholtz coil you can create uniform magnetic field. So there is a lots of application of Helmholtz coil, that in your graduation classes there is a proof also, and there is a typical question in your graduation classes. But for your class 12 this is more than sufficient. For if you put two coil of radius r, and if you there is a distance is r only, then there is a uniform magnetic field in between this. Okay, ठीक है, पढ़ते रहिए. Thank you.